Okay, Bearcats, this is Unit 1 Review Part 2, and we will start with number 8. All right, for number 8, we're asked to determine, we're asked to evaluate a function, and the function that we're given is f of x equals x squared plus 1. And we're asked to evaluate at each function value. So f of 2 for part A. That means we're just going to plug a 2 in for our x. So we have 2 squared plus 1, which is 4 plus 1 are 5. All right, for part B, we're asked to evaluate at -4. So f of -4. Once again, plugging in for x, we have -4 in parentheses squared plus 1. Well, -4 times -4 is a positive 16 plus 1 would give us 17. All right, and for C, we're asked to evaluate at f of t squared. So t squared will replace the x, so be really careful. So we have parentheses t squared and then squared plus 1. So that would be 2 times 2 would be 4, so t to the 4th plus 1, and that would be part C. And part D. Part D, we're asked to evaluate at f of t plus 1. So t plus 1 will replace the x. So parentheses t plus 1 squared plus 1. Now I'm going to use the shortcut for binomial squared. If you don't know that shortcut, you should learn it because it will just save you tons of time over the course every time we have a binomial squared. But understand the shortcut is going to give us the same thing as if we said t plus 1 times t plus 1, foiled and simplified. So it's a shortcut. The shortcut is, if you don't already know it, take the first term, which is t in this case, and square it, so t squared. For the middle term, we're going to multiply everything. So t times 1 times 2 would be positive 2t. And then take the last term, in this case is 1, and square it, which would be 1. And then don't forget we still have plus 1. Simplifying, we end up with t squared plus 2t plus 2 in this case, and that would be our answer for the last evaluate on number 8. All right, let's go on to number 9. Pause if you need to. We're continuing to evaluate, but this time we're evaluating a piecewise function. This is, those graphs that have parts of different types of functions, and they're restricted. And so the first evaluation we're going to ask to be due for 9a will be h of -2. Well, for a piecewise function, you must look at these restrictions. So you have to see which one that fits. -2 would fit the first restriction. -2 would be less than -1. So we would use this equation. So we'd have 2 times -2 plus 1. 2 times -2 plus 1. And we would end up with -3 when we simplified. For part B, we would have h of -1. Again, fitting this top one because it says equal to -1, so we have 2 times -1 plus 1, which would give us a -1 for our output. For C, we're asked at h of 0. Well, 0 would fit the second one. 0 would be greater than -1, so we put a 0 in for the x here, so we have 0 squared plus 2, which would just give us 2. And finally, part D, we're asked h of 2. Again, fitting the second equation where x is greater than -1. So we'd have 2 squared plus 2. That would be 4 plus 2 or 6 would be our output. That's number 9. Number 9. All right, pause and we'll move on with me when you're ready. Okay, taking a look here, we want to find the domain. And remember, with a square root function, the square root function is going to move off in one direction or the other, and there's going to be a range of values that can be true for a square root function, but not all values. So a number line is very helpful in this case. What we do know about a square root function is that the stuff underneath has to be equal to 0 or positive. It cannot be a negative value. So a number line is very helpful here. Remember, what's underneath the radical has to be 0 or positive. So let's see what happens to make it 0. So if we have 25 minus x squared, okay, we're going to figure out what makes this 0. So we'd move the x squared over. We would get 25 equals x squared, or x squared equals 25 square root. We are the artist of that radical, so we need to add a plus or minus, so x equals positive or negative 5. To finish this, we're going to want to know if it's between 5 and negative 5, or if it's greater and less than that. The easiest thing to do is test a center point. Okay, so we're going to check to see if this is between 5 and negative 5, or greater and less than negative 5. The easiest point to test would be 0. If we test 0 and plug it in, we would keep a positive under our radical. So the values between negative 5 and 5 would be our values. So our domain would be the values between negative 5 and 5, including those 2 points. So we would use hard brackets. Go Bearcats. Okay, we're now on 10b. 10b is f of x equals 3x plus 4. I hope that you can recognize this as a linear equation and know that all lines, the domain of all lines would be all real numbers. So as interval notation goes, we'd have negative infinity to positive infinity as our domain. All right, let's look at 10c. 10c is going to be a rational expression, which is a polynomial over a polynomial, and we are going to have some issues with this. We know that in a denominator of a fraction, we cannot have 0 values. It cannot equal 0, be undefined. We need to figure out what those 0 values are going to be. So in this case, I believe we can factor x and x, then values to equal, multiply to negative 6, add to negative 1. That would be negative 3 and positive 2. Therefore, our zeros are 3 and negative 2. So in this case, you could write the domain. It would be a little more complicated, or for me, you may just write the restriction, which would be our domain restriction, would be our x values cannot equal 3 and negative 2. If we wanted to write the actual domain, here's what it would look like. We would have negative 2 and 3 cannot equal these values. So you have negative infinity out here, positive infinity out here. We would have three sets or 3 intervals for your domain. We would have negative infinity to negative 2. We would have negative 2 to 3. And we would have 3 to positive infinity. So this is the actual domain. This is the restriction. I am fine with the restriction. It's a little easier to write. All right, go Bearcats. Let's take a look at 11, which is our difference quotient. Okay, we're going to go through the difference quotient. Hopefully that you know the difference quotient is f of x plus h minus f of x all divided by h, where h cannot equal 0. And why can h not equal 0? Well, that would be a 0 in the denominator, and it would be undefined. So let's take a look at this equation we're given, and we want to find the difference quotient. I'm going to work on A. B is online on my web page in a hard copy form. I'm going to let you go on and look at it. Look at that form. It's just a lot of work, and I think that you'll get the point after we do A. But the part B is already worked out in hard copy if you want to see it online on my web page. All right, so let's take a look at this. First, let's take this apart. We're going to first do f of x plus h. So imagine this is f of x plus h. We would take the x plus h and plug it in for all the x's. That's part 1. So we would have 2 parentheses x plus h squared plus 3 times x plus h minus 1. Then we're going to subtract, that's where the subtraction, and we're going to subtract f of x. F of x is this entire equation here. I'm going to put a parenthesis so I distribute the negative. So it would be 2x squared plus 3x minus 1. And of course, all of that would be over h. Let's go ahead and do some simplifying. We're going to take our binomial squared and use our shortcut again. So we're going to end up with 2 times x squared. Multiply together, you get 2xh. H, the last term squared, would be h squared. We're going to distribute the 3, so plus 3x plus 3h minus 1. And we're going to distribute this negative all the way through. Minus 2x squared, minus 3x, and plus 1. Again, all over h. All right, let's keep going. We're going to distribute the 2. And again, this is just tedious. This is not difficult. It's just tedious, so be really careful in organizing your work. We would have 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 1 minus 2x squared minus 3x plus 1, just copying over all over h. Now we want to go ahead and make some cancellations. If you did this correctly and you were careful in your math, all the terms that have only an x by themselves should cancel. I see, let's do this in a different color. So I see 2x squared would cancel with our negative 2x squared. I see this negative 1 would cancel with this positive 1. I see this 3x would cancel with this negative 3x. And now we're getting down to the last step here. So we have, after all those cancellations, we have 4xh plus 2h squared plus 3h all over h. Each of these in the numerator have an h. We're going to factor out that h, and when we do, we would have 4x plus 2h plus 3 all over h. These h's would cancel, and I think we're finally down to it, 4x squared plus 2h plus 3. That would be your difference quotient. Go Bearcats. Again, look at part B online on my web page. Let's go on to 12. Okay, number 12. We did this in class, but I want to just go ahead and review it with you one more time. Take a look at this graph. You will have a graph to interpret on your test. The graph will be a little different, and there will be a grid behind it, so it'll be a little easier to pick out the numbers. But you do have to understand what we're doing, not just memorize, because the graph will not look like this particular graph. All right, let's take a look at A. A is simply the domain of the given function. The domain would be the x values, and we're going to assume in pre-cal if there's no endpoints that these graphs go on forever. So the x values would move from left and right forever in both directions, so that would be all real numbers or interval notation preferably, which would be negative to positive infinity. Part B asks us the range. Well, the range are the y values, and you can see the lowest part of this graph. Ooh. Wow, messed up my graph there. The lowest part of this graph is at 2, and so we're going to and I didn't mark that 2. That should be a 2. At 2, and so our lowest part of our graph would be 2, and then the graph moves upward forever, so from 2 to positive infinity, and I'm going to make that a hard bracket for the 2 since it's equal at 2. You can never equal infinity, never reach infinity, so it's always a soft bracket. Okay, for part C, we're wanting to know what the slope is. And we're looking at the graph as in its entirety. When the x values are less than or equal to negative 3. Okay, we need to talk about this so that you don't get confused tomorrow. We're trying to help you interpret a graph. So the x values being less than negative 3, I want you to go on your x-axis to negative 3, and I'd want you to go up to your graph, and I kind of go off here, and you're going to hit this part of the graph, this line. Okay, so that negative 3 x value would be on this line right here. So what we're asking you for really is the slope of that line, or that part of a line. The slope of a line is going to be the same no matter where you are on the line. So it might be even easy if you have a grid just to count your slope. You might not even have to do the slope formula. I am going to write the slope formula just a reminder. That would be your change in y, so your y2 minus y1, over your change in x, x2 minus x1. But if we have a line and we're trying to find its slope, we could count the slope out. So from this point to this point, which we know, which is on that same line, and the slope would be the same, we could count up to and over 1. Up to over 1 would give us a slope of 2, but be really careful. This line is a negative slope. So when we go up, we're going to the left, so it's a negative 2. So the slope of this line would be negative 2. Not x, that's not a slope, just negative 2 is the actual slope. All right, let's take a look at D, the distance. And this is one I really do want to talk about because I think this is one that could be a little confusing for you. So pause and make sure that you have this information down, and then focus really hard. Maybe watch this next part before you write anything down. Okay, part D, we're finding that distance between the values where x is 2 and x is 4. So you're going to go back to your graph, and you're going to go where x is 2 and go up to your graph. And at 2, your point would be at 2, 4. Oh, that's negative 2. Sorry. At 2, it'd be at 2, 4. And then you have to look at what happens at 4. At 4, if you followed your graph up, you would be at 8. And I know it's a little hard to tell on here. You will have a grid on your test. So you're going to have a graph at 4, 8. 4, 8. So your two ordered pairs, you're finding the distance between is 2, 4 and 4, 8. Now you could use the distance formula, or again, if you have a grid, you could simply create a right triangle and you could use the Pythagorean theorem. Either way, we did this in class, so hopefully this is familiar to you. I'm going to go ahead and do the distance formula. I know we counted the Pythagorean theorem in class. Our distance formula is the square root of our change in x, so x1 minus x2 squared, and our change in y, y1 minus, or sorry, 2, 1, y2 minus y1 squared. And that's our distance formula, so we can go ahead and do that, or we can count that. Look at this. The x minus x, that's the change in our x value. Well, our x value went from 2 to 4, 2 to 4. So we have 2, or you could go ahead and plug in and say 4 minus 2, which is 2. And from 4 to 8 is a distance of 4, or we had 8 minus 4, which is 4 squared. And we would end up having the square root of 4 squared, which is, or 2 squared, which is 4, plus 16, which I believe gives us 19 or 20, the square root of 20. So our distance in this case is the square root of 20. Now, I will give you maybe a bonus point, or at least a big happy face, if you simplify the square root of 20, but I won't count it wrong if you just leave it that way. Simplified square roots of 20 would be 2 square roots of 5. How would you do that? You could do prime factors, so you could take 20 divided by 2 is 10, divided by 2 is 5. Since it's a square root, you can take out any pair, so that 2 would come out of the house, 5 would stay home. And that would be a simplified version. I would take either one on your test. All right, let's look at E. Okay, for E, we're asked to find the midpoint when x is at -1, when x equals -1. Well, the midpoint of the function actually should be between -1 and 1. And x is 1 right here. It's going to be this line. Oh, my graph keeps messing up. It's going to be this line right here, and I want the midpoint of that segment, basically. If you look at your graph, you're going to see that the midpoint right there is at 0. So at 0, 2 would be your midpoint. You didn't even have to make a calculation to find that. 0, 2 would be your midpoint. Just to refresh your memory, though, the midpoint formula, if you have two endpoints, would be x sub 2 plus x sub 1 divided by 2, and y sub 2 plus y sub 1 divided by 2. And that would be your midpoint formula. And then last is you want to write the piecewise function. The piecewise function. Let's go ahead and see if we can do that really quickly. We already know, let's look at that. I'm going to kind of recreate your graph down here. So what do we know about our graph? We know we have a point here at -1, 2. We'd already found that the slope of this line was -2. We have a point here at 1, 2, and we found that the slope of this line equals +2. And we want the graph. This is a decreasing, constant, and increasing, and we're going to write our piecewise function. So there's 3 parts to our graph. We have this part, we have the constant part, and we have the increasing part. So the constant, remember this is coming forever, so from -infinity up to -1, or up to -1 would be all our x values that are less than -1. So our restriction for that first part would be x values less than or equal to -1. The restriction in the middle would be from -1 to 1 for our x values, so x in the middle, -1 to 1. And then our restrictions for the second or the third part would be from 1 greater than, or when x is greater than 1. Greater than 1. Those are our 3 restrictions. Since we already know that the slope is -2 and we have a point, we could write it in point slope form. So that would be y minus 2 equals our slope of -2, x plus 1. And I will let you just leave it in point slope form if you would like on your test. This constant function is at 2, so our value of our y value at that point is 2, so we just simply say 2. And then our positive slope would be right here, and we would use this point and that slope to write our point slope form, and that would be y minus 2 equals 2, x minus 1. And that would be your equation of your piecewise function. All right, last problem of the night. All right, for number 13, we're asked to write the equation of a line that passes through the point 4, 7, and it is parallel to this equation or this line. Well, to know if it's parallel, we want the same slope as this line, and so we need to find its slope first. It's easy to identify the slope if you put it in slope-intercept form or y equals form. So let's do that. We'd move the 2x over, have 7y equals negative 2x minus 6. And then we would, of course, divide everything by 7. And we're only really interested in the slope anyway. So the slope of that line is negative 2/7. So if I want a line that is parallel, my parallel slope would be the same, 2/7. If I want a line that's perpendicular, my slope would be positive 7/2. So now we're ready to write our equations. We're going to use this point and this slope for our parallel line, this point and this slope for our perpendicular line. We're going to start with point slope form and then go ahead and rewrite in to slope intercept form just for that extra practice. Okay, so point slope form for the parallel line, we would have y minus 7 equals 2/7 x minus 4. If we distribute the 2/7, we would get y minus 7 equals, oh, this should be a negative 2/7, sorry. Negative 2/7 x plus, and negative 4 times negative 2 would be a positive 8, so 8/7. Then what we're going to want to do is add this 7 to both sides. So y would equal negative 2/7 x. Now 7 as sevenths, that would be 7 times 7 are 49/7. It's the same, so we're going to add 8 and 49, and I believe that's going to be 57, so plus 57/7. Now before you panic, I will give you a blue calculator. You can probably add those two fractions, or you can add the 8/7 and 7 together in your calculator. I do want to see this point slope form though first. All right, for the parallel version, we're going to do the same. We're going to have y minus 7 equals 7/2 x minus 4. Distribute again. We have y minus 7 equals 7/2 x. And then this time, 7 times negative 4 is a negative 28/2. Negative 28/2. Now, again, we're going to add the 7 to cancel over here and add the 7 over here. So we'd have y equals 7/2. 7/2 would be actually 14/2. So negative 28 and a positive 14 gives me a negative 14/7, which is actually going to be 2. Actually going to be 2. Oh, not 14/7, 14/2. Sorry, 14/2, which is actually going to be 7. So y equals 7/2 minus 7, and that will be 7/2 x minus 7, and that would be the answer to your perpendicular line in slope-intercept form. I will be fine again with point slope form, and then you can use your calculator to help you from there. All right, that's it. I hope you have a good night. I'll be here early in the morning if you need any extra help. Have a great night. Go Bearcats. Oh, my class would like to say something to you. One, two,
1, 2, 3.
Go Bearcats!